Today we are going to discuss Chapter 1, that is Chemical Reactions and Equations. So let's start the chapter Chemical Reactions and Equation. What is this chemical reaction? A chemical reaction is a process where the reactants gets converted into a product which may be under an influence of a catalyst. What are catalysts? Catalysts are the substance that will increase the rate of reaction. Now, how we can show the chemical reaction? We can write the chemical reaction by using word equation. So, a word equation shows a changes of reactants to products through an arrow placed between them. The reactants are written in the left hand side, that is LHS, by using a positive sign. And similarly, the products are written on the right hand side, that is RHS, by using a positive sign. And the arrowhead points towards the product shows the direction of the reaction. Now, how do we identify a chemical reaction? A chemical reaction is identified by 4 factors. That is, first, change in state. If you are getting any change in states, that time you can speak the chemical reaction takes place. And if you are getting any change in color during the reaction, that time also you can speak that this is the chemical reaction. Next is, if you are getting any evolution of gas when two reactants are combined together and forming a product, that time this is also the identification point of chemical reaction. Change in temperature. If you are getting any change in temperature during your reaction, that time also you can speak that this is the chemical reaction. According to law of conservation of mass, matter can neither be created nor be destroyed in a chemical reactions. And this law of conservation of mass, was given by the scientist whose name is Anthony Lavoisier. He gave this law of conservation of mass. Now, how we can write chemical reactions? A chemical equation represents a chemical reaction. If you recall the formula of the magnesium oxygen and magnesium oxide, the above word equation can be written as the symbol of magnesium is Mg and the symbol of oxygen is O2. When magnesium will combine with oxygen, that time magnesium oxide, that is MgO, will form. So, like this, we can write chemical reaction by using the formulas of the reactants as well as of products. Now, how we can balance the chemical reaction? To balance a chemical equation, first draw a box around each formula and do not change anything inside the box while balancing the equation. Next step, list the number of atoms of the different elements present in the unbalanced equation. Now start balancing with a compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the elements which has the maximum number of atoms. Now balance the unbalanced atoms. Finally, to check the correctness of the balanced equation, we count atoms of each and every element on both sides of the equation. To make a chemical equation more informative, we can express the physical states of the reactants and products also by along with their chemical formulas. Suppose if the gaseous liquid, then we will represent the gaseous state by using small g, and if it is a liquid state, then we can represent the state by using small l. And in the case of aqueous state, aqueous means solution in water. So for representing aqueous, we will use AQ. And for solid state, simply we will use S. The word aqueous is written if the reactants or products are present as in the solution or in water. In this reaction, this is 2H2 plus O2, 2H2O. In the left hand side, in the case of hydrogen, there are the 4 atoms in the case of hydrogen. And in the case of oxygen, there are 2 atoms in oxygen. Now, we have to balance the equation. Then according to balancing, both sides number of atoms should be equal. So here 2 into 2, 4, and here 2 into 2, 4. Now in the case of oxygen, O2. In the left hand side, 2 atoms are there in the case of oxygen. So same as in the right hand side also, 2 atoms are there in the case of oxygen. Like this, we can balance our equation as well as we can make our equation more informative. Now, types of chemical reactions. There are 5 types of chemical reactions. First is combination reaction, next is decomposition reaction, displacement reaction, double displacement reaction, and redox reaction. Now we will discuss each and every reaction in detail. What is combination reaction? The word combination means to combine. So when 2 reactants combine to form a product, it is called a combination reaction. Like calcium oxide reacts vigorously with water to produce slag-like, that is known as calcium hydroxide, and releasing a large amount of heat. So we will represent this statement by equation. The formula of calcium oxide is CaO and the formula of water is H2O. Then when calcium oxide reacts with water, that time calcium hydroxide, that is CaOH whole twice, will form. Calcium hydroxide reacts slowly with carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 or 3 days of whitewashing and gives a shiny finish to the walls. It is interesting to note that the chemical formula for marble is also CaCO3, that is calcium carbonate. Next is reaction in which heat is released along with the formation of products are called exothermic reactions. Burning of natural gas and the decomposition of vegetable matter into compost are also the example of exothermic reactions. Next one is endothermic reactions. Endothermic reactions are those reactions in which heat is absorbed. During digestion, food is break down into simpler substances. For example, rice, potato and bread contains carbohydrates. These carbohydrates are broken down to form glucose, and this glucose combines with oxygen in the cells of our body and produce energy. So this is the example of endothermic reaction. Next one is decomposition reaction. What is this decomposition reaction? When a products break up. Decomposition means to break. So when a product breaks up into its constituent reactants, the reaction is termed as decomposition reaction. Same as in this case, FeSO4, that is ferrous sulfate, will heat and it will decompose into Fe2O3, that is ferric oxide, and SO2, that is sulfur dioxide, and SO3, that is sulfur trioxide. For making this reaction more informative, we can write the physical states of the reactants and products. FeSO4 is in solid form, that's why it is S, and Fe2O3, this is also in solid form, that's why it is S, and SO2 is in gaseous form, that's why G, and SO3 is a gaseous form, that's why here also G. So, decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is the important decomposition reaction, and it is used in various industries. Calcium oxide is called lime as well as quicklime, and it has many uses. One is in the manufacture of cement. When a decomposition reaction is carried out by heating, it is called the thermal decomposition. The word thermal means temperature or heat. Now, electrolytic decomposition. Electro means electricity or charge. So, for this, we will perform an activity. Take a plastic mug and drill 2 holes at its base and fit rubbers in these holes. Insert carbon electrodes in these rubbers stoppers. Now connect these electrodes to a 6-volt battery. Fill a mug with water such that the electrodes are immersed. Now add a few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes like this. This is a beaker. Drill 2 holes in the base of beaker and make it tight by using rubber stoppers. Okay. Now insert carbon electrodes in these rubber stoppers and connect this setup with 6-volt battery. Now take a test tube filled with water and put this test tube in the inverted manner over the carbon electrodes. Now switch on the current and leave the apparatus undisturbed for some time. What you will observe? You will observe that the formation of bubbles at both the electrodes. These bubbles displaces water in the test tube. We will see that hydrogen is at cathode and the oxygen is at anode. And this oxygen is just double of hydrogen in the term of volume. So this is the electrolytic decomposition. Now photolysis. Photo means light, and we can speak thermal decomposition also. Halogen compounds decomposes on exposure to sunlight, like AgCl, silver chloride. If you will keep this silver chloride in sunlight in any china dish, that time because of heat as well as because of light, this compound will break down into silver and chloric gas. Photolytic reaction are used in black and white photography. The decomposition reaction requires energy either in the form of heat or light as well as electricity to break down the reactants. And reaction which gives energy is absorbed is known as endothermic reaction. So what is the endothermic reactions? Endothermic reactions in which energy is absorbed. In this reaction, AgCl will absorb the energy as well as AgCl will absorb the heat, and after absorbing heat, this AgCl will decompose into its constituents. Next is displacement reaction. What is this displacement reaction? When an element displaces another element from its respective compound of lower reactivity, it is said to be a displacement reaction. Like, see, this is a zinc and this is H2S, hydrogen sulfide. When zinc reacts with hydrogen sulfide, that time hydrogen will free and zinc will form a zinc sulfide. So, in this case, zinc displaces hydrogen. One more example, take a copper sulfate solution. The color of copper sulfate solution is blue and put a iron nail in solution. Now leave it undisturbed for 1 week. After 1 week, what you will see? You will see a green color solution and copper metal on the iron. So this green color solution is of iron sulfate solution. This is the displacement reaction. Now some examples of displacement reaction, like when zinc will react with copper sulfate, that time zinc sulfate and copper will form. In the displacement reaction, element will be in the free form. In this case, when aluminium reacts with copper sulfate, that time copper will free and aluminium sulfate will form. And when iron will react with copper sulfate, that time copper will free and iron sulfate will form. When lead will react with plus chloride, that time lead chloride will form and copper will separate. Now, when CaBr reacts with AgNO3, that time AgBr will form and calcium nitrate will form. Now, double displacement reaction. What is this double displacement reaction? A reaction in which there is an exchange of ions between the reactants are called double displacement reaction. These reactions are also called precipitation reaction, as an insoluble substance is formed which is known as a precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. Like in this example, AgNO3 will react with sodium chloride, then AgCl and NaNO3 will form. This is the example of precipitation reaction. Now some more examples of precipitation reaction, that when AgNO3 and potassium dichromate will combine, then it will form a red color precipitate which will insoluble in the solution. Oxidation and reduction reaction. In short form, it is known as redox reaction also. If the substance gains oxygen during a reaction, it is said to be oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. If one reactant gets oxidized while the other gets reduced during a reaction, such type of reactions are known as oxidation, reduction or redox reactions. If a substance gains oxygen or loses hydrogen during a reaction, it is said to be oxidized, and if a substance loses oxygen or gain hydrogen during reaction, it is said to be reduced. See, these are some examples of redox reaction. When sodium and chlorine will combine, that time sodium chloride will form. In this case, sodium loses its electron and chlorine gains the electron. Now, next example, when sodium reacts with oxygen, that time sodium oxide will form. In this case, sodium loses its electron and oxygen gains the electron. Next, when sodium reacts with sulfur, that time sodium sulfide will form. In this case, sodium loses its electron and sulfur gains its electron. Some more examples of redox reaction, like when methane reacts with oxygen, that time carbon dioxide and water will form. In this case, reduces methane will remove its hydrogen, that's why it is oxidation, and oxygen, in the case of oxygen, hydrogen will add, that's why it is reduction reaction. Some more examples of redox reaction. When carbon reacts with oxygen, that time carbon dioxide gas will form. And when magnesium reacts with nitrogen, that time Mg3N2 will form. These all are the example of redox reaction. Next is corrosion and rancidity. When a metal is attacked by substances around it, such as moisture, acid, as well as oxygen, it is said to be corrode. And this process is called corrosion. The black coating on silver and the green coating on copper are the examples of corrosion. Corrosion causes damage of metallic substances like car body, bridges, iron railings, ships, and to all objects made up of metal, especially those of iron. And corrosion of iron is known as rusting of iron. And this corrosion of iron is a very serious problem because in our daily life many things are there that is made up of only iron. What is rancidity? When fat and oil are oxidized, they becomes rinsed and their smell and taste will change. Usually substances which prevents oxidation that are known as antioxidants and are added to the food containing fat and oil. And how we can prevent this rancidity? By keeping food material in airtight containers and help to slow down the oxidation. If we will keep the food material in airtight containers, that time oxidation will slow. And like this, we can prevent our food materials from becoming rinsed. And hence, chips and clutches with nitrogen gas to prevent it from rancidity. So nitrogen is an antioxidant which is using in the manufacturing of chips and other food materials. So children, this is the explanation of the chapter 1, that is chemical reaction and equation. Thank you.